classmates ఎట్లా రాశారు మ్యాథ్స్ ఒకరైతే ఆల్ అవుట్ ఎట్లా
monotonic sequence. A sequence Sn is said to be monotonic sequence if it is either monotonically increasing or monotonically decreasing. Okay. If we cannot say every time it is monotonically increasing sequence, it is monotonically decreasing. If either monotonically increasing or monotonically decreasing, we can say that it is the monotonic sequence. Okay.
Yes, sir.
Next, limit of a sequence. Limit of a sequence means let Sn be a sequence and L belongs to capital R. How the K belongs to capital R is the same. That is the lower bound. But in this, the each and every sequence number is satisfies some relation. So we can say that that is a limit of the sequence. That is, let Sn be a sequence and L belongs to capital R. L belongs to capital R. L is said to be limit of a sequence Sn if to each or for each epsilon is greater than 0, then there exists delta is greater than 0, then there exists small m belongs to Z plus such that modulus of Sn minus L is less than epsilon. That is nothing but limit n tends to infinity Sn equal to L. For example, I discussed with that 1 by Sn equal to 1 by x. Okay. For
Yes,
this,
ma'am.
for n tends to infinity, the limit of Sn equal to 0. Why? Because 1 by 1, 1 by 2, so on. Then when n is approaches to infinity, the Sn sequence value is 0. So it is the example of the limit of a sequence. That is nothing but Sn be a sequence and L is any real value that L satisfies the relation of modulus of Sn is less than Sn minus L is less than epsilon for epsilon greater than 0 for any some particular value. Then we can say that L is the limit of the sequence.
Yes, ma'am. Just 1 second, I will be back. I just go washroom.
Next definition, convergent sequence. A sequence has a limit point, then the sequence is said to be convergent sequence. That is nothing but if limit n tends to infinity Sn equal to L, then we say that sequence Sn is convergent to that limit point. Then Sn is convergent to limit. A sequence has a single limit. Sequence satisfies the limit condition, then that sequence is said to be convergent sequence. Divergent
Yes, ma'am.
sequence means a sequence is not a convergent. That is nothing but it is not approaches to single value. So such type of the sequences are said to be the divergent sequence. The divergent sequence is diverges to either plus infinity or minus infinity. Or and the oscillating sequence is also divergent sequence. Okay.
Yes, ma'am.
In that, how to say the divergent sequence is diverges to plus infinity. A sequence Sn is said to be divergent to plus infinity if for each g is greater than 0, then there exists m belongs to z plus such that Sn is greater than g, then it can be written as Sn tends to infinity as n tends to infinity. The example is, we can take sequence Sn is equal to natural n for all n belongs to z plus. If n tends to infinity, the n is also, the sequence is also tends to infinity. S1, S2, S3, 1, 2, 3, so on. Up to it reaches to infinity, the Sn value is reaches to infinity. So it is a divergent sequence tends to infinity. That is the divergent to plus infinity. And the
Yes, ma'am.
second one is, in this, we can take the another divergent to minus infinity. Divergent to minus infinity means a sequence Sn is said to be divergent to minus infinity if for each g is greater than 0, then there exists small m belongs to z plus such that Sn is less than minus g. That is, it can be written as Sn tends to minus infinity as n tends to infinity. This g value is minus infinity, that is Sn is less than minus g. When n approaches to infinity, the Sn value is approaches to minus infinity. In this, we can take one example. Sn is equal to minus 1 into n, n square for all n belongs to z plus. If n approaches to infinity, S1, S2, it has the negative sign means the n value increases 1 square, 1, 4, 9, 25, like this. It has every value has negative value, so it goes to minus infinity. Okay.
Yes, ma'am.
Next, oscillating finitely, oscillating infinitely. Oscillating finitely means the sequence has negative and positive alternate values, and those end values, the bounded below, bounded above values are real values. That is oscillating finitely. Oscillating finitely means the bounded below and bounded above value is a finite numbers. It's a particular real value. If oscillating infinitely means that is nothing but that goes to minus infinity plus infinity. So how we can define such type of the sequences means a sequence Sn is said to be the oscillating finitely if Sn is bounded but not convergent. Example, Sn equal to minus 1 whole power n. Here bounded but not convergent. but not convergent means convergent relation is it has a limit value. That is, we can take for bounded and convergent means Sn equal to 1 by n for all n belongs to Z plus. This is bounded. Bounded means maximum. Bounded above value is 1, bounded below value is 0. As n tends to infinity, it reaches to 0. So limit of Sn is equal to 0. So such type of sequences are bounded sequence and it is convergent sequence. Okay. Here, this is a bounded. Why? Because S1 equal to minus 1, S2 equal to 1, S3 equal to minus 1, S4 equal to 1. That is nothing but minus 1 is less than or equal to Sn is less than or equal to 1. It has lower bound and upper bound, so it is bounded, but it is not a convergent. Why? Because it has not a single limit value, both end values are
Yes,
there.
ma'am.
So such type of the sequences are said to be oscillating finitely. Okay, oscillating infinitely means same relation, but it has not finite. Infinitely means we can take the best example Sn equal to minus 1 whole power n into n for all n belongs to Z plus. See here, S1 equal to minus 1, S2 equal to 2, S3 equal to minus 3, S4 equal to 4. One is negative, one is positive, not same values. The values are also changes. Such type of the sequences are said to be infinite sequence. That is, we can take n is tends to
Ma'am.
okay a sequence.
Hello, ma'am.
Hello, hello.
Yes, ma'am. Now you're audible. Yes, ma'am. Now
Oh,
you're audible.
okay. Some internet connection is unstable. Why? Because here power cut. A sequence Sn is said to
It's
be
okay, ma'am.
oscillating infinitely if Sn is unbounded, if Sn is unbounded. That is nothing but and divergent. Unbounded but not convergent. Unbounded. Here finitely means bounded. Here infinitely means unbounded but not convergent. That is nothing but example is
Yes, ma'am.
Sn equal to minus 1 whole power n into n for all n belongs to Z plus. Every convergent sequence is bounded, but every bounded sequence is need not convergent. Every bounded sequence is need not convergent. Every convergent sequence is bounded means we can take Sn equal to 1 by n. This is the convergent and it is also bounded. But every bounded sequence is need not convergent means Sn equal to minus 1 whole power n. This is bounded. Minus 1 is less than or equal to Sn is less than or equal to 1. But it is not convergent. It is oscillating. Third one. Limit of a sequence if it exists in unique. If the sequence has a limit of your sequence, that is nothing but the sequence has a limit. Has a limit means that value exactly unique value. Fourth one, if Sn is a constant sequence for all n belongs to Z plus is bounded. This is a constant sequence. It is a bounded. Okay, these are the important definitions in the sequence chapter. Infinite series means the sum of terms of a sequence is said to be series. If the sequence terms are infinite, in series also, we get infinite terms. That is, it is denoted by un, or un is equal to summation Sn. If we can take u1 is equal to s1, if u2 equal to s1 plus s2, u3 equal to s1 plus s2 plus s3, we can take that much summation n equal to 1 to n, that is 1 to infinity. If it has infinite means, then u infinity equal to s1 plus s2 plus so on to s up to so on. This is called as the infinite series. The sum of the sequence terms is said to be the series. If it has infinite, then that is called as the infinite series. If it has finite terms, then the sequence series is called as the finite terms of the series, finite series. Okay. On the infinite series only we can discuss the tests: comparison test, D'Alembert's ratio test, integral test, Rabi's test, logarithmic test, Cauchy's nth root test, Leibniz's test. These all are depends on the infinite series only. In this, we can majorly taking the definitions of some p test and how we can take the comparison in between of the two tests. Okay. First, before discussing of the comparison test, we can discuss about the p-test. From the p-test only we can compare the given test with the p-test. Okay. Here, the p-test means it is very, very important. In this, all tests are important, not only single. The series sigma 1 by n power p equal to 1 by 1 power p plus 1 by 2 power p plus 1 by 3 power p plus so on, for p belongs to capital R. Okay, such that it satisfies one condition, that is that series is convergent. The series is convergent if p is greater than 1 And the second rule is, if it is divergent, if P is less than or equal to 1. We should remember these conditions in the P test. If the series is in the form sigma 1 by n power P equal to sigma expansion, that is the expansion of the sigma is 1 by 1 power P, substitute n equal to 1, 2, 3, 4 up to. Here summation n equal to 1 to infinity means we can take 1 by 1 power P, only n value changes. P is a constant real value. But when it is the convergent series, when it is the divergent series. The convergent series, if P is greater than 1, divergent series is P is less than or equal to 1.
P is less than.
From this only, if the given series is a check by the comparison test, is it convergent or divergent? Test the convergency. They will ask like that questions. If we can compare with the P test means, if P value is greater than 1, we can say that the from the P test 1 by n power P is a convergent, then the given series is also convergent. Okay, that can be applied in the comparison test. Now we can discuss the comparison test. What is the comparison test? If sigma un and sigma vn are two series of positive terms and limit n tends to infinity, un by vn is equal to L, it is not equal to 0, then the series sigma un, sigma vn are 2 or are both convergent or divergent. That is depends on the Vn only. If Vn is convergent series, then Un is also convergent when we can check the relation limit n tends to infinity Un by Vn equal to L. Here Un is a given series, this given series is comparing with the Vn, then those two are having the positive terms only. If the ratio of those two tests is equal to some limit value, then we can say that if Vn is convergent, then Un is also convergent. If Vn is divergent, then Un is also divergent. That we can write as notes. Note. First one. If sigma Un comma sigma Vn are positive terms, positive term series such that sigma Vn is convergent, then sigma Un is also convergent. Second one, if sigma Un comma sigma Vn are positive term series, series such that sigma Vn is divergent, then sigma Un is also divergent. Okay. If both are convergent or divergent means most of the students will get confusion. That's why I am giving the clear detailed information. If both are positive terms, it is says, then if Vn is convergent, then Un is convergent. Why? Because Un is comparing with the Vn. This Vn is depends on the p test only.